Good morning, Mr. Diaz. My name is Salomon, and this is my RoadRunner Logistics project. The, there are four chemicals that needed to be analyzed for this summative, which are calcium chloride, sucrose, sodium chloride, and water. Well, here we can see the chart with the information of calcium chloride as well as the information for sucrose and sodium chloride, as well as water. This information really helps for analyzing and stuff like that. And so the materials I will use for this experiment are distilled water, a hot plate, some ice, tap water, an electronic balance, some glassware, a thermometer, a conductivity tester, a steering rod, and a Bunsen burner. So the number of trials to be conducted for each chemical would be five. I will do it 5 times, so just to make sure. I will be testing the reactions these different chemicals have on ice, and then I will analyze the data by comparing the results. So the number of protons of individual atoms are found in the periodic table, and they're on top of each element box. There can only be a total of 8 balanced electrons and protons for each atom. Each atom has an equal amount of protons and electrons, and they're divided into two groups, the nonmetals and the metals. The nonmetals can be found from 14 to 18, and the metals can be found from 1 to 13. So there are 18 numbered groups in the periodic table, and there are between 3 to 4 groups that are not numbered. There are only two types of bonds, ionic and covalent bonds. A covalent bond is when a metal bonds with another metal, or when a nonmetal bonds with another nonmetal. An ionic bond is when a metal is combined with a nonmetal, or vice versa. Ionic bonds have two categories, anion and cation. These categories help determine if the bond is negative or positive. Nonmetals are the ones that create anions, and metals are the ones that create cations. So for this experiment, I'm choosing sodium chloride. Um, well, chlorides create corrosion, and this may affect a lot of metal components, especially cars, since they're the ones that are going to be using these roads. The corrosion chlorides create may affect a lot of car components such as brakes, parts of the electrical system, paint, and etc. This creates not only an additional cost to vehicle owners, but also creates a safety issue. Chlorides can affect vegetation as well as they can affect the oxygen levels of water. This leads to death of aquatic life. The only big problem with chlorides is how harmful they may be with structures built with concrete, asphalt, or stone. Sodium chloride is the cheapest option. It costs $42 per ton. It may be a little bit less effective than calcium chloride, but the fact that it's about 1/3 cheaper makes it worth it. We're talking about a lot of tons of sodium chloride, and the price does matter, especially for big investments like this. So here's my bibliography. You can click on the links, and thanks.